Welcome to our video over transaction steps in decisions. In this video, we're going to talk about how to use steps that we have set up in case you want to use any of the typical transaction principles that you might use in updating or changing things in a database. So inside decisions in a flow, we actually have the ability to complete the typical transaction process that you might use if you're running something in a database. If you're not familiar, a transaction process is essentially a way to set up a transaction and to run a number of different items that you want to complete in your database all at the same time. And then once all those items have been completed, then it will officially commit those and actually mark them through. If at any point any one of those transactions fails for any reason, it can roll back so that all of those things don't actually happen or change in the database. So it's kind of like an all or nothing approach. I either want all of these things to happen or I want none of them to happen. And that's one of the important principles of transactions. But within decisions, we actually have 3 steps that you can use to create transactions. And so if you want to start building those up, you can do that. So to find them, we can go to all steps, and under the database category, there is a transaction section here that has 3 steps as well as a rule that you could use to check if something is currently in transaction. So if you just want to check if a process is in transaction at any given time, you can easily check that rule as well. But then we have our main 3, the start transaction, the commit transaction, and the rollback transaction. These 3 options are required in order to set up your transaction process in order to have something run. And your basic transactions process is going to look something like this, where you're going to start the transaction. You're going to have a number of whatever steps that you need to change your database or to affect your database. And then your commit transaction that's going to officially set all of those things to actually update the database. And then on some kind of rollback if your commit were to fail for whatever reason, so that it can roll back and none of those changes will actually persist. It can be important in a lot of cases to make sure that you don't have just one thing happening versus other things, always happening. So that rollback is going to be important. To set this up, we essentially just need each of those 3 steps, whatever steps you want to do to make changes in your database, and set them up somewhat similarly to this. There may be some differences here and there depending on your use case that may kind of change, but this is just a very basic, simple demonstration here. On the commit transaction step, there's only one outcome path, which is done. But like in all steps in decisions, you can add an outcome for exception. So we'll suggest that you add an outcome for exception here to send it to your rollback step. That way you can make sure that it does roll back if any errors were to happen on the commit. And there's a lot of cases that this could happen. If there's any kind of like deadlock or something like that that could be blocking, there's a lot of things that are trying to happen at the same time. Maybe in a real case, you might have a lot of updates that are trying to happen, so it could block a certain update from happening. And anytime it were to have an exception, we want to make sure that it can roll back so that any of those changes, don't actually fully happen. And so to demonstrate this very briefly, I have 2 steps in here, one that's going to update someone's bank account to subtract some money from it, and one that's going to update their bank account to add money to it. So I just have 2 random examples here where one person has a balance of 0 and one person has a balance of 900. And so if we run these steps, it'll update those balances to make sure that they actually have the correct transactions occurring in their bank accounts. So if I debug here, it's going to run through, no issues. They changed with the bank updates. And then if I refresh over here real quick, you'll see now this one increased and this one decreased. And so that's the idea here. If everything runs successfully, it's going to increase one balance and decrease the other balance at the same time. Now, let's say I want to run this again, but I don't want this to work. I want it to fail. Now, I'm going to force a fail by just making this ID ignored because this is something that's required in order for it to update properly. Just to give the general idea, but again, you can think of a lot of different ways that in a real use case, if a lot of things are trying to happen at once, or if you're hitting a limit on space in a database or something like that, there's a lot of cases that this commit might not work. So there's various ways that it could fail, but I want to just demonstrate to get the point across. If I go to try to run this, it's going to fail. And if I had just run this normally, this step should have occurred first, updating the amount in the first bank account, but the second bank account failed. And so if normally, if I ran this, this would have updated, this would not have updated. But since I am running it with these transaction steps, neither of those things will actually commit and go through. And if I were to, refresh my data just to see what the current data is going to be in this use case, then I'll see that there was no change. And so then we can see here, no updates were actually made in the data here, right? If I were to jump back to this and do the exact same thing, but remove this from my transaction steps in my process and just have it run like this, as if I was just running two steps here and I don't include them in the transactional steps, and I make these same updates, it'll still fail here, but because it reached this step, as soon as I go to check my data, and I refresh to see the data that changed, you'll see this value did not change because this is the step that it failed on, but this value did. And obviously in real use cases, this could be bad. We don't want one thing to update and the other thing to not update, because I guess in this person's it's positive because they just gained money and this person didn't lose money. But you kind of have to think about, what's going to actually happen in that transaction. And if this was the opposite, where one person lost money and the other person lost money too, right, or didn't gain money, then that wouldn't necessarily be a good thing. So these transaction steps is a great way to ensure that all of the changes and items and things that are being made, that are getting adjusted in the database, are actually persisting and are happening, exactly when they need to happen in the process. And transaction steps is a great way to do that. So by simply placing them in between within these transactions like we have here, and having this set up to run, this allows us to make sure that we actually do get all of these updates happening and committed, and any issue were to happen, we wouldn't see those issues persisting in the database side of things. So that's the kind of basics of how these transaction updates work. Hopefully that gives you a good idea and a good view into how you can set those up to set those transaction steps and use any transactions in your databases in a real use case. Thank you for watching.